Hello, hello, my dear friends. Hello, my. Anyone in live? Hi, Ra, Pranit, hi. Hmm. Now, before let others to join. అందరు రాని అందరు వచ్చే వరకు we'll wait. Once we'll recap the last class what we have studied, so that it will be continuation for this our lecture. Last class up to we have done preparations of the alkane. In that preparations of the alkane we have seen with the red phosphorus and the HI. Now today we'll start with the physical property, then after that very one important reaction of our which one very one important reaction of our alkanes, then after we'll go with the alkenes. Today the class length duration may be up to 12, I mean until that alkanes if complete I will continue the class today. Okay na? Alkenes complete ga chemical properties తో with questions తో సహా అయిపోయే వరకు కంటిన్యూ చేస్తా క్లాస్. So be concentrate. Alkenes, preparations of alkenes and applications of the alkenes is very important. It will play very crucial role and the key role. Done? Now next, in the last class we have studied, right? In the last class we have studied about the what is the nucleophile and what is the base. Now when it will act as a nucleophile and when it will be act as a base already we have seen. Just once the key step. Now many of the students they are having the mistake in this, right? Now you can see here. Once we will recap to the last class what we have studied, so that it will be easy for us the continuation of this lecture. Now in the last class we have seen the when the nucleophile and the base when we have to consider same and when we have to consider the nucleophile and the base different. Clear? If the same nucleophilicity site, if the same nucleophilicity site if it is having, then we have to consider which one? What we have to consider? If the nucleophilicity site if it is having same, nucleophile and the base order will become same. Nucleophile order and the base order will become same. Then if the nucleophile and base order will be different when the different nucleophile but they belong to the same group they have to belong. If they belong to the same group, now what? Nucleophile order and the base order will be different. Nucleophile order and the base order will become different, right? Next, now case 3, then nucleophile and base order will be same but nucleophilicity is different or nucleophilicity site is different. When it will be happen? When they have belong to the same period. When they belong to the same period, that already we have seen. This is the first key point. Only what is the key point already I explained. What? Strong acid conjugate base. Strong acid conjugate base is a which one? Good living group, because they are stable but they are not that much good nucleophile and the base. Which one? Because they are stable. The negative charge on the which one, oxygen or any other atom, that it is stabilizing. Due to that stabilization, what happens? Due to that stabilization, its basic strength or nucleophilicity strength will be decreased. Done. That we have studied in the last class. Then after that, rearrangement. Now methyl shift, hydride shift, and the ring contraction, ring expansion, that all we have seen. When the ring expansion will be happened, when the ring contraction will be happened, that already I explained very clearly. Now next, then after that we have seen the preparations of the alkane. In the preparations of the alkanes with the different reaction, Woods reaction and decarboxylation, and the next one, what type of the reactions we have seen? Coal based electrolysis. Next, Clemmensen reduction, Wolff-Kishner reduction, that all we have seen. Clear? Done. Now we'll start with the physical properties. Now if anyone are in the live, they can just say me the hi, so that I will start the class. If anyone are in the live, they can say me, or they can text a hi in the chat box, so that I can start the class. Good evening, Suhas. Good evening. If anyone are in the live, they can text a hi, so that I can start the class. From the physical properties, we'll start. Because already we have studied in the last class up to we have studied the preparations of the alkanes. Now today we are going to study. Now if any students who are in the live, only Suhas I can see, Pranit I can see. If any other are there, just so that I will have some idea who are listening to the class. Just you text a hi, or say me the hi. Now we'll start the class. Now the physical properties of alkane. Physical properties of the alkanes. Now in the physical properties of the alkanes, now these physical properties, first one, in the physical properties of the alkanes, first one we are going to see, alkanes are almost non-polar. We know why we are considering alkane as a non-polar, because this carbon and the hydrogen electronegativity almost we will consider it as a equal, because we know this electronegativity of carbon and the hydrogens we consider equal. That's the reason whatever the bond between them, these are the non-polar. That's the reason it will not undergo any addition reaction. Alkanes will not readily undergo which reaction? Addition reaction. Clear? What the alkanes will readily undergo? Which reactions the alkane will readily undergo? Can anyone? Which reactions mainly the alkanes will readily undergo? What is the condition required for the alkanes to react? Because these are the non-polar. Because the alkane sigma bond, whatever the sigma bonds is present in the alkanes are strong, that we know. Sigma bonds are the strong bonds, we know. Done. Substitution. Okay, good. Which substitution? Which substitution reaction? Which substitution reaction it will undergo? 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 Can anyone, which substitution reaction it will undergo? Now it will undergo mainly it will undergo the free radical substitution reaction, right? Done. Now here now we'll see. First one, carbon and the hydrogens are the which one? Non-polar we will consider, right? Then next we will see the branching. Next we will see the branching or boiling point of the boiling point of alkanes. Now the boiling point of the alkanes will be depend upon their what? Surface area and van der Waals force. Their van der Waals force will depend upon their surface area. Alkanes mainly the boiling point will be depend upon the surface area. Means as the branching in alkanes increases, what happens? Boiling point decreases. In the alkanes branching increases, boiling point decreases. Why? Because if you take the straight chain alkane, if you take the pentane, then this one will be the clear. Now this one is the 2-methyl butane. Then if you take the neopentane, done. Now you can see in the neopentane surface area is less. Now here the compared to the n-pentane and compared to the which one? Isobutane. Here what it has happened? Sir, isobentane. Here what it has happened? Hi. Now here this all surface area, when the surface area decreases, what happens? Boiling point decreases. Clear? Next one. When it comes to the melting point here for the alkanes, it is having some different type of the compared to the all the one. Now the melting point for the alkanes, it is having somewhat different. Why it is having the somewhat different means melting point for the alkanes, it is somewhat different. Why? Because we know the carbon and the carbon in the alkane, carbon hybridization is a sp3, and in the alkanes carbon hybridization is a sp3. sp3 means zigzag. In the zigzag manner will be there, because we can write the alkane in any manner. In this manner we can write, in this manner we can write, any manner we can write, right? In this manner we can write, anything we can write, because alkanes we can write in the zigzag manner. Due to that zigzag manner, it is having the what? It is having the some different melting point than our expected. Clear? That it will be depend upon the closely packing or crystal lattice. Clear? And symmetrical structure. How come? Now I will explain which one is having the higher melting point and which one is having the lower melting point. See, up to C1 to C4 carbons, now odd carbons melting point, compared to the odd carbons melting point, and odd carbon melting point is higher. How come the odd carbon melting point is higher? Here if you take propane, it is having the melting point 55.3 Kelvin, and when it comes to the butane it is a symmetrical. Now it's having the melting point approximately 138 Kelvin. Then when it comes to the pentane, 1, 2, 3, 4. Now when it comes to the pentane, it is having the 143.3 Kelvin. very nominal melting point will be there. Odd number of carbons melting point is higher and even number of the carbons melting point is somewhat lower. This is about the melting point. Done. Next their nature. What is the nature? C1 carbon to C4 carbon. C1 carbon to C4 carbons are gaseous. These are gaseous. Then C5 carbon to C17 carbons, these are liquids. Done. Above C18 are solids. Above C18s are the solids. Clear? Now this is about the physical properties of the which one? This is about the physical properties of alkanes. Now we are going to study the which one? Chemical properties of the alkane. Now listen carefully. This is very important and repeatedly they are asking. Now how come the photohalogenation or we can say the free radical reaction of the alkane? How the alkanes will react very fastly. Now why only it will readily undergo the free radical substitution? Now why only it will give you the reaction with the Cl2 or H or heat? Now with the proper mechanism I will explain. Now listen carefully. Now chemical properties of alkane. In the chemical properties of the alkane, first reaction we are going to see the free radical reaction of the alkane. Done. Or we can say it as a halogenation reaction of the which one? Alkane. Now we'll go. Now we'll see first one we can say it, we can take it as a free radical substitution reaction of alkanes. In the free radical substitution reactions of the alkanes, now mainly here we are going to take what? RH. This is one alkane. Alkane in the presence of what? One halogen in the presence of H nu or heat. What it will give? It will give the one alkali halide and one HX. Clear? Here the intermediate is carbon radical. Here we are going to see. And here the X, here whatever the X2 we have taken, right? Here the X2 is only either Cl2 or Br2. Why not the F2 and why not the I2? I will explain. Done. Now this is about the free radical substitution reactions of the alkane. Now we'll see the mechanism one by one. Now first step one. What is the step one? What we have to do? We have to initiate the reaction, right? Now to initiate the reaction, what I was taking first, to initiate the reaction we are having the halogen X2. In this halogen X2 I was giving the heat. When I was giving the heat, what it will happen? Homolytically it will be break. These two halogens homolytically it will be break and it will be converted into 2x radical. Here we have given the heat to this one, right? We have given the heat to this one. Now which type of the reaction this is? Endothermic or exothermic? Can anyone? In the step one, what we are doing? Now we are making the halogen radicals. Right? Now we are giving the heat. If we are giving the heat to this one means, now if we give the heat means, now which type of the reaction? This is exothermic or endothermic? This is exothermic or endothermic? This is endothermic because we are giving the heat to break homolytically. When we are giving the heat to break homolytically, clear? Now done. Now when we are giving the heat to break this one, what it is happening? Clear? Endothermic. The first step is endo. First step is endothermic. Now listen carefully here. What it will happen, you know? When already to break the which one halogen, we have given the heat. Already we know the free radical is a highly reactive and highly explosive. Here then after the which radical, here the radical it has formed, right? Now this radical in the step 2, what it will do? Now what we are having? We are having the alkane, right? Now in this alkane and this radical, this alkane and this radical, here two types of the reaction it will be happened. What? This halogen is having possibility to take this radical of hydrogen, because if it is homolytical, if it has broken, now here we will generate the R radical as well as the H radical. Then this whatever the radical we have generated here, this radical is having the what? Having the chance to take the bond or radical of the hydrogen, and it is having the chance to take the radical of the R. Then which one is a stable and which one will be the chain propagation, that it will be depend. Already we have given the heat here to start the reaction. Still if you give the heat, what it will happen, you know, in the free radical reaction it will become explosive. Still if you give the heat, already we have given the certain amount of the heat to break this radical. Then whatever the radical here it has generated, that radical here, if it is taken the bond to the hydrogen, R radical will be generated. Done. Plus here the HX. Then if this radical, if it has taken the or given the bond pair of electron to the R, then what it will happen? Now it will form the Rx and it will generate the H radical. It will generate the H radical. Now here you see most of the cases H radical is unstable. Done. H radical is unstable. Here whatever the HX it has formed here, depending upon this bond energy only the reaction will proceed. If this X radical, if it is given this bond pair of electron or any this this radical, if it is given to the hydrogen radical, what it is happening? Here it is forming the HX. If it is given to the R, it is forming the Rx. But here which is more stable? Here the R radical is somewhat more stable than the H radical, and here the depending upon this HX bond strength only reaction will be proceed. What? Depending upon this HX only. Here if you take here it as a F, here HF will be very explosive. Here whatever the HF it will form, it will be very explosive. And if you take the HI, whatever the HI it has formed, that is a strong reducing agent, again the reaction will be very explosive. And why the HI is not, we are not going to take in the here, or I2, why we are not going to take? Because that I radical or HI which has formed here, that is a strong reducing agent. So that is also very explosive. That's the reason only the Cl2 and Br2 will be used as the X. Because here whatever the bond it will be formed, either HCl, either the HBr. When the stable bond formed, what it will happen? When the stable bond formed, energy released or energy absorbed? When the stable bond formed, energy released or energy absorbed? When the stable bond formed, energy released or energy absorbed? Can anyone? When the stable bond formed, energy released, energy or absorbed? Here whatever the HX it is forming the stable. HX it is forming the stable. Energy released means in the step 2 energy is releasing. In the step 2 what it is happening? Energy is releasing. In the step 2 energy is releasing. Due to that released energy, what? In the step 2 whatever the energy it is releasing by the bond of the HCl or HBr. If you have taken the Cl, here it will form the HCl. If you take the Br, here what it will form? HBr it will form. Due to that energy only reaction will be proceed. Due to that reaction only it will be proceed. Because why the fluorine and why the iodine we will not take? You got it right? If you take the fluorine, here the HF is explosive. If you take the I2, here the HI is what? Strong reducing agent, or it will be, what it will happen? what it will happen? It will convert the reaction backward. That's the reason here the HI we are not taking. Then the only the suitable are Cl2 and the Br2. Here the when it is formed the Cl2, exothermic reaction is happening, reaction is proceeding. Because now when the energy has been released in the reaction, there is no need any chance to take the energy from the outsource. Done. Now in the reaction, in the step 2, now we are going to the step 3. Now what is the step 3? Here in the chain propagation step already many radicals has been generated. What? One R radical will form the bond with R radical. Now X radical will form the bond with X radical. Now and the R radical it will form the bond with X radical. Clear? Now this type of the reactions it will form R and the X2, and here it will be the Rx. In this manner what? Free radical substitution reactions of the alkane will be happen. Means very key step is here whatever the bond it is forming. Here if it is a stable bond, if it is formed, energy released, then the reaction will be proceed. If it is unstable bond, if it is formed the HF, here the process is endothermic. Endothermic means energy release, and that's the reason we used to say if you take the F2 in the free radical substitution reaction, it is explosive. It is explosive. Clear, right? Done. Next. Done. Now how the alkanes will be reacting with the Cl2 and all, now we'll see. If I was taking the CH4, done. This is a CH4. CH4 in the presence of Cl2 and H nu excess or Cl2 excess if I was taking. Now what is the product we will get? What is the product we will get? Can anyone? CH4 and the Cl2 excess if I was taken, what is the product I will get? Now what is the product I will get if I take the CH4 and the Cl2 excess H nu? Then the product I will get, because whatever the hydrogens it is there, that all it will be converted into, or all it will be replaced by the Cl. Clear? And it will be converted into CCl4. When next, if suppose if I was taken the CH4 excess, then and the Cl2 in the limit, then what it will happen? Now here the Cl2 is in the limit, right? It will replace only one hydrogen. It will convert into methyl chloride. It will convert into the methyl chloride. Done. Next. Here next, the very important and the very confusion question that every student they are facing, that if suppose 2-methyl butane if they are given, and in the presence of Cl2 H nu if they have given, now here how many possible products we will get, and which among them is more stable they will ask. Which among them is the more stable they will ask. Clear? Now here how many replaceable hydrogens are different from of the hydrogens we are having, that we have to see. Then after that, after the different form of the hydrogens after we are seeing, right, then what we have to do? Then we have to attach, or we have to substitute the Cl over there. Then here the how many different types of the hydrogens we are having, now we'll see. The different types of the hydrogens we are having. Here this hydrogen or this carbon hydrogen and this carbon hydrogens are same. Then this hydrogen is different. Next, this hydrogen is different. This hydrogen is different. Next, when it comes to this hydrogen is also a different. These two yellow color hydrogens are in the same nature, and the white color hydrogens are in different nature, and this red color, the carbon which contain the hydrogen, it is having the different nature, and green color carbon containing hydrogens are having the different nature. Sir, how we will get to know, sir? Then how you will get to know means you will get to know by the IUPAC name. If suppose here the 3 hydrogens we are having, here we are having the 3 hydrogens, right? Here also we are having the 3 hydrogens. Then here we are having the 1 hydrogen. Here we are having the 2 hydrogens. Here we are having the 3 hydrogens. You may get a doubt. Sir, here this is a primary carbon, here it is also a primary carbon, here it is also a primary carbon, and all the primary carbons will have the same nature of the hydrogens, sir. Then how you are saying this this green color carbon containing hydrogens are having the different nature? Then how it is having the different nature means, now you see, if this chlorine has replaced any of this hydrogen from this one carbon, I will give you the numbering better so that it will be very clear for you. One carbon, this is 2 carbon, this is 3 carbon, this is 4 carbon. Okay, 1 carbon hydrogen if it is replaced, now what it will get? Here the Cl. Done. Now this is a one product. Then second product, if the 2 number carbon hydrogen if it is replaced, now this is a product we will get. Then 3 number carbon chlorine if it is replaced, we will get the this this product. And if it is replaced with the 4th number carbon product or 4th number carbon hydrogen if it is replaced, now we will get the this product, right? Now here, no, Suhas, once again you are doing the same mistake. White one is more stable, that white one is not more stable. White one is not more stable. You are seeing, by seeing that, which one? By seeing that you are saying that this is a 3 degree carbon, it has 3 degree radical. 3 is more stable, because you should not say on the basis of which one. Simply you should not say on the basis of the 3 degree radical. You have to say on the basis of selectivity ratio. Selectivity ratio will play very crucial role here. Okay, now we'll see. Here if you write the IUPAC name for this one, more substituted alkene will, no, here why no, here you can see this chlorine, if this chlorine, what is the IUPAC name of this chlorine? This is a 1 chloro 2 methyl butane. The name of this compound is 1 chloro 2 methyl butane. If suppose this carbon or this carbon hydrogen if it is replaced, then what it will happen? Here it will form 1 chloro 3 methyl butane. 1 chloro 3 methyl butane is different and 1 chloro 2 methyl butane is different. Both the IUPAC names are different. Both the compounds IUPAC name is different. So if both the compounds IUPAC name is different, its physical property is also different. Sorry, its chemical properties are also different. Then that's the reason these hydrogens are having the different nature. Then which among these 4 which is more stable, they will ask. For that one you have to be very careful. Simply by seeing that 3 degree radical is more stable, so 3 degree substituted chloride or 3 degree substituted halogen is a more stable, we wish to think, but we should not decide on that base. Manam aa base lo choosukoni cheppakudadu. How we have to decide? We have to decide on the basis of selectivity ratio. What is the selectivity ratio? Now selectivity ratio of the which one? Halogens. Selectivity ratio of the halogens, first Cl2 and the Br2. If it is replaced with the 1 degree hydrogen, if it is replaced with the 1 degree hydrogen, then it is 1. If it is replaced with the 2 degree hydrogen, it is having the 3.8. If it is replaced with the 3 degree hydrogen, it is having the 5. Then if it is replaced with the 1 degree hydrogen of the bromine, if the bromination happened, if it is replaced with the 1 degree hydrogen, 1. 2 degree hydrogen, 80. And the 3 degree hydrogen, 1600. Done. This is about the which one? Selectivity ratio. Now this is about the selectivity ratio, right? Now we'll see and we'll calculate the selectivity ratios for this one. Now here how many 1 degree hydrogens we are having? Same nature of 1 degree hydrogens. Same nature of 1 degree hydrogens we are having 6, right? 6 into 1, 6. Done. Now same nature of 2 degree hydrogens are how many? 2 degree hydrogens of same nature we are having 2, because here 1 2, right? 2 into how much? It is a 3.8. Then it will give you the 7.6. Done. Now 3 degree hydrogen of same nature will be 1. 1 into how much? 5. This will be 5. And this is 1 degree hydrogen, it is having the different nature, right? This 1 degree hydrogen, it is having the different nature and it is having 1. So 1. Total if you calculate, Total if you add, it will become 21.6. Then by this 21.6 we have to find out which one will give you the more percentage. More percentage it will give. See, this carbon has replaced the 1 degree hydrogen of the 6, right? Now we'll see how much percentage it has formed. 6 by 21.6 into 100 if you do, you will get the percentage of this one. Now here 3 degree hydrogen it has replaced, right? Now it is having the 5, right? So 5 into 5 by 21.6 into 100 if you do, you will get the percentage. Now here it has replaced the 2 degree hydrogens, right? That is 7.6 by 21.6 into 100 if you do, you will get. Now here it is having the 1, right? It is having the how many hydrogens here? It is having 3 hydrogens, right? Sorry, 3 into 1. Sorry. 3 into 1 it will be 3. 3 into 1 it will be 3. Sorry. Now here we are having the what? 3 by 21.6 into 100 if you do, you will get the percentage. By seeing the percentage, now you have to say which one is a more percentage or more stable here, or highest yield it has giving. Based on the selectivity ratio only, you have to say when the chlorination happens. When the chlorination reactions they have given, based on the selectivity ratio only, you have to say, not on the basis of simply by the whether it is a 3 degree radical it is giving, 1 degree radical it is giving, 2 degree radical. Depending upon the selectivity ratio, you have to see and you have to select. Now you can see it is having the higher number. Here it is having the higher number, almost it will give the higher percentage. May I know how much percentage it will give? Can anyone say how much percentage it will give? May I know how many it will give? How much percentage it will give? Can anyone? This third one, how much percentage it will give? How much percentage it is giving? Calculate it and say me, Nana. 7.6 by 21.6 into 100. Around 33 or 35. Among all the four, now this is giving approximately 33 to 35 is saying, right? So this one will be the higher field and it is a more stable. Done. Now this is a very most important reaction of the alkane. Done. Whenever the alkanes they have given, alkanes upon Cl2 in the presence of H nu or the heat if they have given, Cl2 if they have given, blindly you should not decide. You have to decide on the basis of selectivity ratio. Then if suppose bromine if they have given, blindly you can go for the 3 degree. Because bromine 3 degree value is having how much? 1600. So blindly you can go. Bromination if they have given, blindly you can go for the which one? 3 degree. But chlorine if they have given, you should not go blindly. You have to decide. Then next one. Next type of the next all are the reactions which we are having. Those are simple reactions. Those are simple reaction. Just I will write it and I will leave. Because these are not that much important, but just we have to study, right? See, nitration. Nitration. What is the nitration? Can anyone say nitration reagents? Nitration reaction reagents. Now alkane upon the nitration if you take HNO3. HNO3 in the presence of at high temperature, what it will give? NO2 as a NO2 it will be generated, and here the two possible NO2s it will get. One is a primary NO2 and one will be the secondary NO2. Done. If suppose 2-methyl butane if they are given and the HNO3 if they are given, HNO3 if they are given at the high temperature, now here how many products we will get? How many replaceable hydrogens we are having? That many products we will get. Here one it will get from here. Here it will be the NO2. Now the second one will be the in the middle 3 degree and the next one will be the say 2 degree. Now these are the 3 possible product we will get. Next one we are having sulfonation. Next one we are having the sulfonation. Nana, I just want to inform you that now the rain has started. Maybe in middle, if suppose current, if it is gone, now the live will be ended. Okay, until the current it will be there, I will continue, because now itself the rain started. Rain ఇప్పుడే వర్షం స్టార్ట్ అయింది. కరెంట్ ఎప్పుడు పోతుందో తెలీదు. కరెంట్ ఉన్నంతసేపు కంటిన్యూ చేస్తా క్లాస్. ఓకేనా? కరెంట్ ఒకవేళ పోయింది అంటే విల్ కంటిన్యూ ద క్లాస్ టుమారో. Done. Sulfonation. Now, what is the sulfonation? When alkanes, a sulfonation reaction manaku telusu. Now, what is the sulfonation reaction? Oleum. If you take the oleum, now that oleum, what it will give? That is H2S2O7. H2, not H2SO4, oleum. H2S2O7, oleum. Now, that it will give you the sulfonic acid. It will give you the sulfonic acid plus H2O. Done. Next, very important, sometimes in the conversions it may useful for us. In the conversion case it may be useful for us, that is isomerization. What is that? Isomerization. Now, what is the meaning of the isomerization? Now, alkanes are heating with the AlCl3 at high temperature. What it will happen? Branching it will give, or 1,2 hydrate shift or 1,2 methyl shift will be happen. If you take 1, 2, 3, 4, 5, 6. Now, in the presence of AlCl3 at a 570 Kelvin, because alkanes will not readily react with the low temperature. Alkanes required high temperature because sigma bonds are strong to break. Clear? The sigma bonds are the strong to break. That's the reason we require higher energy. To break the stable bonds, we require the higher energy. Done. Now, one isomerization will be happen. Now, the second isomerization will be possible here. Done. Now, these are the two isomerization possible for this one. Clear? Now, next, if suppose if they have given in this manner, now AlCl3 plus HCl at a normal temperature, if they have given, what it will happen? Now 2, 3 dimethyl butane it will form. 2, 3 dimethyl butane it will form. Next one will be the aromatization. Next one will be the aromatization. Aromatization means any compound to show aromatization. This alkene to show the aromatization, alkenes with 6 or more carbons, when heated. This here for the aromatization, what you have to remember? Reagents you have to remember, because these reagents will be helpful for us in the conversion question. If you remember the which one? Reagents, it will be helpful for us in the which one? Conversion question. Under pressure of under high pressure of catalyst. Under high pressure of catalyst. Example, this catalyst are Al2O3 plus Cr2O3. Clear? Next, V2O5 plus MO2O3. Clear? Now, these are the some catalysts that we are going to use. At a high temperature, at a 773 Kelvin, at a 10 to 20 atm pressure. And now, how it will be happen? Now, if you take the 6-membered ring, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. First, if you take the V2O5 or Al2O3 plus Cr2O3 if you take, first what it will happen, it will be converted into the cyclohexane. Cyclohexane upon PD or platinum, PD or platinum at 600 degrees Celsius if you take, what it will happen, it will, whatever the hydrogen as a H2 gas, it will be removed from the cyclohexane and it will convert into benzene. It will be converted into benzene. So you have to be very careful. Whenever this type of the reagents they have given, this type of the reagents if they have given, cyclohexane will be converted into benzene. Cyclohexane will be converted into benzene. Can anyone say if suppose heptane if they have given, heptane upon V2O5 or PD in the presence of PT at 600 degrees Celsius. May I know what is the product we will get it here? And what is its name? May I know what is the product we will get it here and what is its name? What is the product name? The one who is in the live, they can say. Now what is the product we can expect here? What is the product we can expect here? 1-methyl benzene. Common name of this one? What is the common name of 1-methyl benzene? What is the common name of 1-methyl benzene? What is the common name of 1-methyl benzene? Toluene, Nana. Why we are getting confusion? Toluene, right? Toluene, that's it. 6-membered ring will be converted into benzene and the remaining will be the CH3. This is toluene. Simple. Methyl benzene. Toluene. No, not anisole. No. Not anisole. Anisole ante ether functional group undali kada. Correct only. Toluene. Next, catalytic oxidation. Next is a catalytic oxidation. Next one we are having the catalytic oxidation. Now catalytic oxidation means when CH4 and O2 at 9:11 proportion when it are heated at a 100 atm pressure, when they are heated at the 100 atm pressure through copper wire at a 470 Kelvin. Now CH4 is oxidized to alcohol. Which alcohol? Methyl alcohol. Then this 2 moles of CH4 plus in the presence of limited oxygen. Now what it will converted? It will converted into the CH3OH. Now if suppose alkane if they have given and alkaline KMnO4 they have given. Alkane if they have given, this is 2-methyl propane. 2-methyl propane upon alkaline KMnO4. We know alkaline KMnO4 is a strong oxidizing agent. What it will convert? It will convert into the which one? 3-degree alcohol. Why? It will take the one hydrogen and it will be converted into the alcohol. Now we will see how this KMnO4 is converting or how it is oxidizing the CH4. Now we will see. Here this is a CH4, right? CH4 now due to the presence of strong oxidizing agent, whenever in the chemistry if you have seen this symbol, then you have to consider that this is a oxidization or strong oxidization symbol. Means whatever the species that is present here, that it will be oxidizing the which one? reactant. To make you confused, sometimes they will give you this symbol in the bracket, and if you give in the O, that it is meaning that oxidation. Now the KMnO4 is a strong oxidizing agent, we know. Then what it will do? First it will convert it into the which one? It will convert it into the which one? Alcohol. Then again we are having the 3 hydrogens, right? How many hydrogens we are having? That many hydrogens it will be replaced from the which one? Carbon. Then here again, here we are having the 3 hydrogens. In this 2 hydrogen, in this 3 hydrogen, 1 hydrogen will be oxidized. Again it will be oxidized to the alcohol. Now we know that 1 carbon bearing the 2 alcohols are unstable. So as the elimination of H2O will be takes place, then it will be converted into which one? Formaldehyde in this manner. In this manner the formaldehyde it will be converted. Again this formaldehyde, again further oxidized to the which one? Formic acid. Again this will be converted into the formic acid. But formic acid, it will not be more stable in this manner. Or formic acid again if you further oxidize, it will be converted into, how it will be converted? Formic acid upon oxidation, already I explained very clearly. If suppose if you remember, you can say, if not I will, if not you can give me the question mark. If you know you can say, if not you can give me the question mark, so that I can say. A formic acid upon further oxidation, what it will give? Formic acid upon further oxidation, what it will give? Formic acid upon further oxidation, what it will give? Formic acid upon further oxidation, it will give you the CO2 plus H2O. Formic acid upon further oxidation, it will give you the CO2 plus H2O. This is about the complete chemical properties of the which one? Alkanes. Then this is about the complete preparation methods of the alkanes. Done? No. Here in the complete preparations of the alkanes, here wait. Right. Now we are going to start the alkanes. Now I am going to start the alkanes. Now listen carefully, Nana. These reactions are very, very important. If you listen this alkanes reaction, if you listen the alkanes reaction, in the alkanes reactions itself, I will cover the which one? Elimination reaction E1, E2, E1Cb. Your 25% of the alloalkane reactions will be covered itself. In which one? In the preparations of the alkane. In the preparations of the reactions of the alkenes itself, I will cover the E1, E2, E1Cb. There itself I will cover. Then how to use, how to apply that E1, E2, E1Cb also I will explain there itself. Means half of your alloalkane reactions will be completed in the preparations of the alkenes only. So listen carefully. Now if you are having any doubts in the middle of the class, just you can what you can do, you can give the question mark in the chat box. Chat lo question mark ఇవ్వండి, నేను అక్కడ మీకు ఎక్కడెక్కడ అర్థం కాలేదో మళ్ళీ క్లియర్ గా ఎక్స్ప్లెయిన్ చేస్తా. Done. Now here first, here we are going to see, sure, 1 minute, alkanes. Now we are going to see the alkanes, sorry, alkenes. No. Okay, fine. Okay, you can leave, no problem. Now you can see some other time. It will be recorded and it will be present in the channel itself, right? You can see. Next, general formula of the alkene will be CnH2n. Then hybridization of the alkene will be sp2. Now the general name of the alkene will be olefin. General name of the alkene will be olefin. Done. And the functional group of the alkene will be C double bond C. C double bond C. Done. Now degree of unsaturation for the alkene will be 1. And carbon double bond carbon bond length will be 1.34 angstroms. 1.34 angstroms. Clear? Done. Now in the preparations of the alkenes, first preparation we are going to see by the dehydration of alcohols. Dehydration of the alcohols, first reaction we are going to see. Done. Now before going to start the dehydrations of the alcohols, you have to be very clear with the what reagents we are using. What are the reagents we are using to do the dehydration of the alcohol? Dehydration means removal of the H2O, we know. So the first reagent that we are going to use, reagents we will see. What are the different reagents will do the dehydration reaction? Reagents. First reagent that it is happening or that it is going to use, that is concentrated H2SO4 at a high temperature, at a 443 to 453 Kelvin. Clear? Then next one, Al2O3 at 380 degrees Celsius or 653 Kelvin. Done. Next, third reagent that we are going to see, H3PO4 at 470 Kelvin. Done. Next, another reagent that we are going to see, heating with P2O5 or P4O10, both are same only, phosphorus pentoxide. Done. Clear? Next reagent that we are going to see, heating with the POCl3 in the presence of pyridine. And next one we are going to see the heating with the KHSO4. Then these are the reagents that we are going to use in our preparations of the alkene or dehydrations of the in the dehydration reaction. Now depending upon the one reaction, now we'll see. Here first thing, whenever the alcohol they have given and concentrated H2SO4 they have given, alcohol they have given and concentrated H2SO4 they have given, many of the students they will think that it will give you the alkene, because this reaction we are studying, it is a which reaction? Dehydration reaction. But you have to be very careful with the temperature given. Temperature will play very crucial role whenever the concentrated H2SO4 they have given on the which one? For the alcohol. ఒకవేళ ఆల్కహాల్ ఇస్తే టెంపరేచర్ విల్ ప్లే వెరీ క్రూషియల్. కాన్సన్ట్రేటెడ్ H2SO4 ఇచ్చి 110 డిగ్రీ సెల్సియస్ ఇచ్చిండు అంటే ఆల్కహాల్ ఇట్ విల్ స్టాప్ ద రియాక్షన్ ఎట్ సల్ఫోనిక్ యాసిడ్ స్టేజ్. ఒకవేళ కాన్సన్ట్రేటెడ్ H2SO4 ఇచ్చి ఒక 140 డిగ్రీ సెల్సియస్ ఇచ్చిండు అంటే దిస్ రియాక్షన్ విల్ బి కన్వర్టెడ్ ఇంటూ విచ్ వన్? ఈథర్. ఇది ఆల్కిన్ గా ఎప్పుడు కన్వర్ట్ అవుతుంది అంటే కాన్సన్ట్రేటెడ్ H2SO4 ఇచ్చి నౌ ద టెంపరేచర్ వీ హ్యావ్ టు మెయింటైన్ అరౌండ్ ద 160 to 170 డిగ్రీ సెల్సియస్ మెయింటైన్ చేస్తేనే then it will be converted into the alkene. This is very important, you have to remember. So Concentrated H2SO4 will do the dehydration reactions of the alcohol only at this particular temperature, at the high temperatures only. So concentrated H2SO4 and this temperatures if they have given, now different products we are getting. If suppose 110 degree they have given sulfonic acid, if suppose 140 degree they have given, now what? Ether. If suppose high temperature they have given alkene. High temperature if they have given that it is giving the alkene. Done. Now already why it is giving the different temperatures, and about this two products mechanism I will explain when the alcohols, phenols, ethers chapters. When I was start the alcohols, phenols, ethers chapter, there I will explain very clearly this how these two mechanisms are forming. Just to have a basic idea, I was explaining here, because the temperature will play very crucial role to give the alkene. Done. Next another every students they will get the confusion whenever the concentrated H2SO4 they have given, directly it will give the alkene. No, temperature will play very important. Next, that type of only another reagent is also there. Which one? If you have taken the alcohol and Al2O3, aluminum trioxide if they have given, that also if you have maintained at the 240 to 250 degrees, 240 to 250 degrees Celsius if you have taken, now alcohol will be converted into the ether, but only at the high temperature Al2O3 at something in the around 360 degrees Celsius, then only the alkene will be formed. These two reactions are very important. So temperature, how the temperature is playing very crucial role in the which one? When we have taken the reagents, H2SO4 we have taken high temperature it should be maintained, and Al2O3 also if you have taken what? High temperature it should be maintained. Nominal temperature it is maintaining, the product it is converting into the ethers. Now we'll see the mechanism how the alkene it is giving at a high temperature. If suppose, now what is the compound name? This is 1 2 3 4, clear? 3-methyl butanol, 3-methyl butane 1-ol, 3-methyl butane 1-ol upon concentrated H2SO4. Now in the concentrated H2SO4, we know this H2SO4 will give you the hydrogen. Now oxygen, here oxygen, now you have to say me oxygen, this lone pair of electron is given to the H plus, means here the oxygen is acting as a nucleophile, oxygen is acting as a base. Can anyone, any student, if they are in the live, they can say me, they can text they can text their answer in the chat box. Now if the oxygen lone pair of electron is giving to this H plus, means now here the oxygen is acting as a nucleophile or base. It is acting as the nucleophile or base. It is acting as a nucleophile or base. Can anyone? Base. Good. Now, wow, here electron density donated to the hydrogen, it will act as a base, right? So it will donating its electron density to the base, so it is acting as a, now it is acting as a base and it will form the oxonium ion. Now it will form the oxonium ion in this manner. Now after the forming the oxonium ion, now oxonium ion, this is a oxonium ion. This is oxonium ion. Now oxonium ion, oxygen bearing the more electronegative atom bearing the positive charge is unstable, so it will take this bond pair of electron as the H2O. H2O is a good leaving group, we know. As the H2O it will be eliminated. When as the H2O it has eliminated, as the H2O it has eliminated, now what we will get? Carbocation as the intermediate it will be generated. But I explained very clearly In the yesterday itself I explained very clearly. Now what I explained here, whatever the carbocation it has generated in the as an intermediate, it will be rearranged until it feel the stability. ఆ కార్బోకేటయాన్ అంటిల్ అది దానికి స్టెబిలిటీ వచ్చే వరకు అది రీఅరేంజ్ అవుతుంది. సో దిస్ ఈస్ a 1 degree carbocation, it is unstable. So here this carbon it is having the 2 hydrogens. Now this carbon 1,2 హైడ్రైడ్ ఎట్లా 1,2 హైడ్రైడ్ షిఫ్ట్ అవుతుందో నిన్న బేసిక్స్ ఆఫ్ హైడ్రోకార్బన్స్ లో ఎక్స్ప్లెయిన్ చేసిన. వన్స్ ఇఫ్ యూ హావ్ మిస్డ్ యూ కెన్ సీ దట్ వీడియో ఇన్ అవర్ ఛానల్. క్లియర్? 1,2 హైడ్రైడ్ షిఫ్ట్ ఇక్కడికి షిఫ్ట్ అయినప్పుడు మనకి ఏ కార్బోకేటయాన్ వస్తుంది? విల్ గెట్ ద విచ్ కార్బోకేటయాన్? 2 degree carbocation. Then after that still we can make the more stable carbocation. Here we have to remember the migrating aptitude. Migrating aptitude also will play very crucial role. In the migrating aptitude ఇక్కడ మనకు CH3 ఉంది, ఇక్కడ CH3 ఉంది, ఇక్కడ హైడ్రోజన్ ఉంది. You may get it out, sir, why not you are migrating the CH3, why only you are migrating the H? If I migrate the CH3 here, again it will generate the 2 degree carbocation only. So there is no any use of the which one? Migrating the CH3. So only I will migrate which one? Hydrogen. Then the according to the migrating aptitude also hydrogen is first, then the phenyl, then will be the CH3. This is the migrating aptitude you have to remember. Then here the hydrogen when it has migrated here, then what? Which degree carbocation we are getting? Now we will get the 3 degree carbocation in this manner. When we get the 3 degree carbocation, now depending upon the heat, here the alkene will be produced. Now which alkene will be produced here? Now that here, now after making stable alkene, after making the stable carbocation, after making the stable carbocation, okay, you can leave, Nana. The one who is having the power cuts, they can leave, no problem. Now after making the stable carbocation, now the one who is having the power issues or anything, they can leave from the class, no problem. Now it will be in the channel itself, right? You can see whenever you require. But I will continue. నా కరెంట్ పోయేంతసేపు నేను కూడా కంటిన్యూ చేస్తా. ఓకే? After making the stable carbocation, what we have to do? Then hydrogens should be eliminate. Hydrogen should be eliminate from that carbon which produce stable alkene. ఏదైతే స్టేబుల్ ఆల్కీన్ ఇస్తుందో అక్కడి నుంచి ఆ కార్బన్ నుంచి హైడ్రోజన్ వెళ్ళిపోవాలి. ఎందుకు? స్టేబుల్ ఆల్కీన్ అంటే మోర్ నెంబర్ ఆఫ్ ఆల్ఫా హైడ్రోజన్స్. ఏ కార్బన్ నుంచి హైడ్రోజన్స్ తీస్తే మనకి స్టేబుల్ ఆల్కీన్ వస్తుందో అక్కడి నుంచి హైడ్రోజన్ తీయాలి. ఓకే? నౌ ఈ స్టేట్మెంట్ గుర్తుపెట్టుకొని నౌ విల్ సి ఏ కార్బన్ విచ్ కార్బన్ విల్ గివ్ యూ ద మోర్ స్టేబుల్ ఆల్కీన్. నౌ విల్ సి. నౌ ఇక్కడ 1 2 3 ఇక్కడ పాజిటివ్ ఛార్జ్ ఉంది. ఇప్పుడు నేను ఈ పాజిటివ్ ఛార్జ్ ఫస్ట్ హైడ్రోజన్ ఇక్కడి నుంచి తీస్తా. 1 నెంబర్ కార్బన్ నుంచి హైడ్రోజన్ తీస్తా. 1 నెంబర్ కార్బన్ నుంచి హైడ్రోజన్ తీస్తే ద ప్రొడ్యూస్డ్ ఆల్కీన్ ఇస్ దిస్ వన్. ఓకే? నెక్స్ట్ ఈ 1 నెంబర్ కార్బన్ ఆల్సో సేమే. ఇప్పుడు 2 నెంబర్ కార్బన్ నుంచి తీస్తా. 2 నెంబర్ కార్బన్ నుంచి హైడ్రోజన్ తీస్తే ఇక్కడ హైడ్రోజన్ కదా, ఇట్లా ఇక్కడ హైడ్రోజన్ ఉంటుంది కదా, ఈ హైడ్రోజన్ ఇక్కడికి షిఫ్ట్ అవుతుంది, ఈ హైడ్రోజన్ ఇక్కడికి షిఫ్ట్ అవుతుంది. ఒకవేళ 2 హైడ్రోజన్ నుంచి ఇక్కడ ఈ హైడ్రోజన్ తీస్తే ఈ హైడ్రోజన్ ఇక్కడికి షిఫ్ట్ అవుతుంది, ఈ హైడ్రోజన్ సిగ్మా బాండ్ ఇక్కడికి షిఫ్ట్ అవుతుంది. దెన్ ఇఫ్ ఐ remove the hydrogen from this second number carbon, now the produced alkene, among the 1 and 2, which one is a more stable alkene? Can anyone say? Among the 1 and 2, which one is a more stable alkane? Among the 1 and 2, which one is a more stable alkane? Among the 1 and 2, which one is a more stable alkane? Can anyone say? 2 is a more stable alkene because due to the more number of alpha hydrogens. Due to the more number of alpha hydrogens, 9 alpha hydrogens, it is having, due to that it is more stable. Due to that it is more stable. And this type of the product we call it as a which one? Sedgwick alkene. This one we call it as a Sedgwick alkene. Done. This product we call it as a Sedgwick alkene. And less stable alkene, if it is producing, that we call it as a Hoffman alkene. Clear? Lesser, which one? Lesser stable alkene if it is producing means Hoffman. More stable if it is producing means Sedgwick. That's it. This one. Next one. Next type. Second type of the reaction. Done. If suppose H plus and heating if they are given. In the first one case we have seen the hydrate shift. Now what we are doing? Now in the second one, now again oxonium ion will form. Oxonium ion will form as a H2O, it will be direct. I was writing nana. Don't get confused. ikkada kochina tarvata emaytadi, ikkada it will take the hydrogen and it will form the oxygen, will get the positive charge and it will get H. ఇదే సేమ్ ఇలా ఫామ్ అవుతుంది. ఇలా ఫామ్ అయ్యి ఏమవుతుంది, ఈ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్ తీసుకొని ఈ కార్బోకేటైన్ ఫామ్ అవుతుంది. డైరెక్ట్ ఈ కార్బోకేటైన్ రాస్తున్నాను నేను ఈ రియాక్షన్కి. డైరెక్ట్లీ ఐ వాజ్ రైటింగ్ దిస్ కార్బోకేటైన్. దెన్ ఆఫ్టర్ ద కార్బోకేటైన్ అగైన్ దిస్ కార్బోకేటైన్ విల్ బి రీఅరేంజెస్ అంటిల్ ఇట్ ఫీల్ ద స్టెబిలిటీ కదా. ఇది ఇక్కడికి మూవ్ అవుతుంది. ఇక్కడికి మూవ్ అయిన తర్వాత then here we'll get the stable carbocation, 2 degree carbocation. 2 degree carbocation still it is less stable. More we can make the more stable carbocation. How? Here we are having the CH3. ఇక్కడ 3 CH3లు ఉన్నాయి కదా. ఈ 3 CH3లో 1,2 హైడ్రేట్ షిఫ్ట్ అవుతుంది. సరే ఇంతకు ముందు దాంట్లో మీరు CH3 మైగ్రేట్ చేయొద్దు, ఓన్లీ హైడ్రోజన్ మైగ్రేట్ చేయాలని. కానీ ఇక్కడ అన్ని CH3లే కదా, హైడ్రోజన్ లేనే లేదు. ఆల్ ఆర్ CH3. So that's the reason we are migrating the CH3. When we are migrating this CH3, now we will get the which one? Stable alkene. Now in this manner, the stable alkene will get. Clear? Stable alkene. Then after generating the stable alkene, now the hydrogen should be eliminated. Okate point gurtu pettukondi nana. What is the key point? Now after generating the stable alkene, after generating stable alkene, after the generating the stable alkene, hydrogen will eliminate from carbon which contain less hydrogens. ఏ కార్బన్ దగ్గర అయితే లెస్ హైడ్రోజన్స్ ఉంటాయో ఆ కార్బన్ దగ్గర నుంచి హైడ్రోజన్ వెళ్ళిపోతుంది. ఆఫ్టర్ మేకింగ్ ద స్టేబుల్ ఆల్కీన్ వాట్ యూ హ్యావ్ టు డూ, ద కార్బన్ విచ్ కంటైన్ లెస్ నెంబర్ ఆఫ్ హైడ్రోజన్స్ ఫ్రమ్ దట్ కార్బన్ వాట్ హైడ్రోజన్ విల్ బి ఎలిమినేటెడ్ టు గివ్ ద మోర్ స్టేబుల్ ఆల్కీన్. ఇక్కడ ఏ కార్బన్ దగ్గర లెస్ నెంబర్ ఆఫ్ హైడ్రోజన్స్ ఉన్నాయి? నో, హియర్ దిస్ కార్బన్ ఈస్ హ్యావింగ్ ద less number of hydrogens, right? Now from this carbon, now the hydrogen will be eliminated. Clear? And it will produce a more stable alkane. See, now this alkene is having the how many hydrogens? 12 alpha hydrogens. If this hydrogen is eliminated from this one carbon, let us assume if the hydrogens are eliminated from this one carbon, now what it is getting? Now it is getting in this manner. See, H, here the CH3, here it is a CH3. Now you can see here this alkene is having the how many alpha hydrogen? This alkene is having only the 4 alpha hydrogen. But this alkene is having how many alpha hydrogen? Now you can see this alkene is having the 12 alpha hydrogen. So it should give the more the number of alpha hydrogens, more is the stability, right? More the number of alpha hydrogens, more is the stability. That's the reason. Clear? Only one point you remember. After making the stable alkene, we have to eliminate the hydrogen from the which one? Which one? Carbon which contain less number of hydrogen. Next example. దీంట్లోనే next another type of the example for the alkene. If you take the CH2OH, then again H plus heating, H plus heating. After making the H plus heating, now this oxygen lone pair of electron will be abstract. Again as oxonium ion it will be eliminated. Now it will get the CH2 plus. Many of the students they will make the mistake in this compound only. Why they will make the mistake in this compound, you know? Here they will think that here the carbon it is having the 1 degree carbon, ikkada hydrogen untadi, so we can shift the hydride shift to here. If you shift the hydride to that carbon, then it will become the CH3 and here it will get the positive charge. And what I said, now the carbon which contain the less number of hydrogens, the carbon which contain the less number of hydrogens, from there they will eliminate the hydrogen and they will think that this is the correct product. And they will think that this is a correct product, but actually this path or this product is wrong. Even though it is producing the 3 degree carbocation, even though it is producing the 3 degree carbocation, because it's what it will happen, it is having some, this is 5-membered ring, 5-membered ring, it is having some angle strain. Now to minimize that angle strain, this carbocation will be expand to the 6-membered ring to feel the less stability, to feel the more stable. This 5-membered ring which it is having the 3 degree carbocation, to minimize that one, to feel the more stability, what it will happen, it will increase its ring to the 5-membered to the 6-membered ring. So the one very key point you have to remember here, what is the one very key point you have to remember? Yesterday also I explained very clearly. If a ring adjacent carbon, if the ring carbon adjacent carbon, if carbon positive charge, if the carbon positive, if it is having ring expansion takes place. What happens? Ring expansion takes place. This is a very very key point you have to remember. ఏదన్నా కార్బన్ కి అడ్జసెంట్ కార్బన్, ఏదన్నా కార్బన్ అడ్జసెంట్ కార్బన్ కి పాజిటివ్ ఛార్జ్ ఉంది అంటే ఆ కార్బోకేటయాన్ విల్ బి స్టెబిలైజ్డ్ బై ద రింగ్ ఎక్స్పాన్షన్. కాకపోతే ఇక్కడ హైడ్రైడ్ షిఫ్ట్ అవ్వదు. Most of the students they will think that here the hydride shift will be happened, and in the exam also మీ ఆప్షన్స్ లో ఇది ఉంటది, పక్కా ఇది ఉంటది. Most of the people they will choose this option and they will come, but actually this is wrong. Okay, now how the ring expansion will be happen, now we'll see. Now this is a CH2 and this is a plus. How the ring expansion will be happen, now give the numbering 1 2 3 4 5 and 6. E bond pair of electron will be shifted toward the 6. Then when the bond pair of electron has been shifted toward the 6 will get the negative charge and 1 will is having the positive and the 2 carbon will get the positive and the 6 and the 1 will form the bond. Now again you give the numbering 1 2 3 4 5 and 6. Done. Then after the forming the 6-membered ring, now the here 1, here the 2 member we are having the positive, here the 3, here 4, here 5 and here 6. 1 carbon and 3 carbon having the same number of hydrogens, right? Ikkada 2 hydrogens unnai, ikkada 2 hydrogens unnai. So hydrogens can be eliminated from any of the carbon. So what we will get? Cyclohexene. Cyclohexene is the product we will get. Done. Cyclohexene is the product we will get. Now next, if suppose they have given in this manner, okay, can anyone say the IUPAC name of the product? Can anyone say the IUPAC name of this product? ట్రై చేయండి. ఇది ఈ క్వశ్చన్ whatever the question I was given, now try to predict the product and say me its IUPAC name. Okay. I will wait for the 1 minute. I will wait for the 1 minute. Preet. May I know? Hello, Preet. Hello, Preet. Hello, Preet. Now, what is the IUPAC name of the product? Try to cross check. Sir, is it hello, Preet. Yeah, Pranit. Chebra. Pranit, నీ ఆన్సర్ రాలే ఇంకా. 1,3 dimethyl cyclohexane 1-ene. Good. 1,3 dimethyl cyclohexane 1-ene. Good, Nana. Good. Clear? Now, how this lone pair of electron will be given to the H plus? When this lone pair of electron has been given to the H plus, now here it will get the positive charge. Now here having the clear. After that, what happens? 1,2 hydrate shift will be happened. Then after the 1,2 hydrate shift, then what happened? Ring expansion. Then ring expansion. After the ring expansion, here we will get the positive charge. Then here we are having any chance to ikkadne vastada positive charge. Yes, here we will get the positive charge. Now the hydrogen, either it can be shift from this carbon or this carbon, anywhere it will be same. So again 1,2 hydrate shift will be happen. After 1,2 hydrate shift, now if the carbocation, if it has came here, then the hydrogens, here we are having the 2, here we are having the 2. Then what it will give? It will give you this product. 1,3 dimethyl cyclohexane 1-ene. Cyclohexane 1-ene. Clear? Good. Now this is a stable product. Next for that one, if suppose the ring carbon only, the OH is attached. If suppose the ring carbon only the OH is attached, then what happens? Then the ring expansion will not be happen. Then here the one key point you have to remember: if the ring carbon if it has positive charge, if it is have the positive charge, then no ring expansion happen. Then there is no any ring expansion happens. Only hydride or methyl shift happens. Only the hydride or methyl shift will be happen. Done. After you are getting the positive charge, this is a 2-degree carbocation. We can make the more stable carbocation by shifting 1,2 hydrate shift. Then after making the 1,2 hydrate shift, we will get the more stable carbocation. After getting the more stable carbocation, here we are having the hydrogens. Here we are having the hydrogens. Then what it will get? More stable alkane. More stable alkane will get in this manner. And next. Now here next one. Now you have to say me, I will write the products. I will write some questions. Now which among the following will readily undergo dehydration reaction fastly? You have to say me. This is 1. Now this is 2. Now this is 3. Now among the 1, 2, 3, which one will readily undergoes? Which one will be readily undergoes dehydration reaction very fastly? Can anyone? Among the 1, 2, 3, 4, which one will readily undergo dehydration reaction very fastly? 1. Order. Can anyone say the order? Order చెప్పు. Pranit order చెప్పరా. 1, 2, 3. Good. Sare. 1, 2, 3. Okay. Now this type of the questions if they have given. ఇలా నార్మల్ లో ఇచ్చినాడు. ఒకవేళ స్టీరియో కెమిస్ట్రీ ఇస్తే ఇప్పుడు if suppose the stereochemistry if they have given ఇక్కడ CH3H ఇక్కడ OH ఇక్కడ H ఇక్కడ H H plus heating. Okay, now here two types of the possible product. Now ఇక్కడ మనకి హైడ్రోజన్ ఫైనల్ ప్రోడక్ట్ ఇవ్వాలి అంటే ఇప్పుడు ఈ ఆక్సోనియం అయాన్ వెళ్ళిపోయినాక తర్వాత ఆక్సోనియం అయాన్కి వెళ్ళిపోయిన తర్వాత మనకి హైడ్రోజన్ ఆర్ హైడ్రైడ్ షిఫ్ట్ అవ్వాలంటే ఏం చెప్పినా ఆ కార్బోకాటయాన్కి హైడ్రోజన్ ట్రాన్స్పోజిషన్స్లో ఉండాలి. హియర్ ఇఫ్ సపోజ్ ద cyclohexane they have given, for this cyclohexane if this OH if it is eliminated, now here we will get the positive charge. For this positive charge we have to shift that hydrogen which are in the trans position. Okay, the trans hydrogens are here 1 and here 2. This is trans hydrogen 1 and let's suppose this is trans hydrogen 2. Now which hydrogen will give you the stable alkene? ఏ హైడ్రోజన్ ని మనం హైడ్రైడ్ షిఫ్ట్ చేస్తే ఆర్ ఆల్కిన్ లోకి కన్వర్ట్ చేస్తే ఏది స్టేబుల్ ఆల్కిన్ ఇస్తుంది? వన్ హైడ్రోజన్ స్టేబుల్ ఆల్కిన్ ఇస్తుందా లేకపోతే 2 హైడ్రోజన్ స్టేబుల్ ఆల్కిన్ ఇస్తా? వన్ హైడ్రోజన్ విల్ గివ్ యూ ద స్టేబుల్ ఆల్కిన్ బికాస్ ఇట్ విల్ గివ్ ద మోర్ సెట్ ఆఫ్ ప్రోడక్ట్. ఇప్పుడు ఈ 1 హైడ్రోజన్ ఇక్కడికి తిప్పితే ఇది H2O గా వెళ్ళిపోతుంది కదా. Then we will get the what? More alpha hydrogens will get. If suppose if you remove the which one? 2 number hydrogen. Then if you remove the 2 number or if you want to stabilize with the 2 number hydrogen, then what it will get? Lesser alpha hydrogen products you will get, sir. Here what it will get? ఇక్కడ alkene కి ఏముంది? Less alpha hydrogens. Here 2, here 1. Only it is having the 3 alpha hydrogens. ఇక్కడ ఎన్ని ఉన్నాయి? 3, 5 and 7 alpha hydrogen. So here also whenever the cyclohexane or stereochemistry if they are asking, now that hydride or methyl or phenyl will be rearranged which are trans to each other. ఇక్కడ కూడా హైడ్రోజన్ కూడా that carbon the hydrogen will be eliminated from that carbon which is trans to the carbocation. Here this is very very important and you have to be very careful. Next let's suppose ఇలా ఇచ్చినాడు. 1, this is 1, now 2, now this is 2, now 3, now this is 3, and this is 4. Now among the 1, 2, 3, 4, which is a more, or which is a more stable, or which one will be readily undergo dehydration reaction very fastly? 1, 2, 3, 4. 1, 2, 3, 4. Which one will be readily undergo dehydration reaction very fastly? Order you say me. Order. Among the 1, 2, 3, 4. 1, 2, 3, 4. Why? Reason? Reason behind it. What is the reason behind it? Less strain. Good. Correct. Less strain. 1, 2, 3, 4. Because 6-membered ring, 6-member carbocation, 5-membered, 4-member, and the 3-member, due to the lesser ring strain. This is about the dehydration of alcohols. Next, second type of the preparations of the alkene, that is alkynes on partial hydrogenation. Gives alkene. On partial hydrogenation gives the alkene. Then how the partial hydrogenation gives the alkene? Now we'll see. Alkynes on the partial hydrogenation. So here the two types of the reaction we are having, or two types of the reagents we are having, that you have to remember. One is R C triple bond R dash. Now this upon in the presence of which one? Lithium or sodium in the presence of liquid ammonia. Next, here H2 in the presence of palladium or BaSO4. With poisonous sulfur or quinoline. Done. Then what these two reagents will do? Now this reagent we call it as a Birch reduction. This one we call it as a Birch reduction. Done. Now this reagent we call it as a Lindlar's catalyst. Now here alkyne upon Birch reduction, we know it will give you the transalkene. Now alkyne upon the Lindlar's catalyst, it will give you the cisalkene. Okay, how it will give the transalkene and how it will give the cisalkene? Now we'll see. First one will go with the which one? Mechanism. First we'll go with the mechanism of Birch reduction. How the Birch reduction mechanism it is giving? Now we'll see. Here we are having the which one? Alkyne. Here it is 1 R, and here it is a 1 R, and here it is a 1 R. Done. In the Birch reduction we are having the metal. Clear? Now this, if this alkyne carbon, if it is shifted towards the which one? This any of the carbon, because this is symmetry, any of the carbon it can shift. Then what it has happened? This carbon will get the which charge? Negative charge. This carbon will get the negative charge, and this carbon will get the positive charge. Then lithium will readily lose the 1 electron, right? that last electron of the lithium will be gained by this carbon. Then what we will get? It will be converted with the one carbon and one radical. Done. And here this negative charge contain the 2 electrons. Done. Now this radical and this negative charge electron, they will repel to each other. Now due to that repulsion, what happened? It will rotate so that it will be free from the repulsion. Now due to that rotation, what it will happen? Now here it will be the radical. Now here the carbon, here it is having the negative charge, and here it is a R, and it is having the R. Now we are having the what? Liquid ammonia, because in the Birch reduction we are having the liquid ammonia, right? You can see here we are having the liquid ammonia. Now in this liquid ammonia, from this liquid ammonia we will get the H plus. Liquid ammonia will be dissociated in this manner. Now that liquid ammonia, that H plus, it was gained by this carbanion. Now R, here the radical. Now it will get the H, and here it is a R. Then again here we are having the which one? Li. Lithium, again it will lose the one electron. That again it will, that electron, it was gained by the carbon. Again it will be converted into the minus, and here it is having the H, and here it is having the R. Again we are having the what? H plus in the solution. That H plus, it will go and attack, and we will get the alkene in this manner. We will get the trans alkene in this manner. In this manner, the trans alkene will get. Done. In which one? In the Birch reduction. Now next. Now next we'll see next here, 1 minute. Now how the Birch reduction trans alkene it is giving, now we have seen. Here next one, if suppose then Lindlar's catalyst, if they have given Lindlar's catalyst, in the Lindlar's catalyst, now what it will happen in the Lindlar's catalyst? In the Lindlar's catalyst, here this is R, C triple bond, C R. Then H2 in the presence of palladium or BaSO4, quinoline or poisoned sulfur, quinoline or the poisoned sulfur, what it will happen? This hydrogen homolytical it will break, and that here also it will homolytical it will be break, and this hydrogen it will go and attack to this carbon, because homolytical when it has broken, this one will get the radical and this one will get the radical, right? This radical of the hydrogen it will be attached, and this radical of the hydrogen it will be attached from the same side, and this poisonous sulfur and the quinoline, what it will do? It will stop the reaction at alkene stage. What is the role of the quinoline will do? It stops reaction at a alkene stage. It will not allow further to go into the which one? Alkane. Clear? That's the reason it will stop the reaction at alkene stage. When it has stopped the reaction at the alkene stage, then what we will get? We will get the alkene in this manner. Done. Which alkene we got? Cis alkene we got. So here the one statement based questions they will ask. What they will ask? Now Birch reduction and Lindlar's catalyst. Birch reduction and the Lindlar catalyst will give what it will give? Geometrical isomers. Both are the geometrical isomers. Birch reduction and the Lindlar catalyst reactions are the which one? Both are geometrical isomers. How? One will give you the cis and one will give you the trans. One will give you the cis and one will give you the trans. Then if suppose, here you have to be very careful with the reagent also in the when the Lindlar's catalyst question they have given. If suppose 2-butane if they have given, 2-butane, if the 2-butane if they have given, And in the 2-butane, if suppose H2 palladium in the presence of barium sulfate, clear? If suppose nothing if they have given, or H2 in the presence of palladium or platinum if they have given, done. Directly what it will happen, alkene will be converted into alkane alkane. Done. If suppose the sodium in the presence of liquid ammonia, plus ethyl alcohol, if they have given, what it will get, you will get the trans alkene in this manner. Next, if suppose sodium in the presence of liquid DT3, deuterium if they have given, in the place of hydrogen, if suppose deuterium they have given, then what it will be added here? Deuterium only will be added. Only the deuterium will be added. Okay, because whatever the hydrogens it is adding to the which one? Nitrogen, or you can see this radical which has added H plus which has came from the, or this carbanion which has added H plus which has came from the ammonia. In the same way here also from the deuterium D will come and it will be attacked to the what? Carbanion, and it will give the trans. So you have to be very careful and you have to see the reagent also. If the H if it is given, now the products will be in the H. If suppose the D if they are given, now the products will be in the D. Clear? Done. Next, if suppose, now I will give you the one question. Now you have to say me the product name. If suppose if they have given the 1-butane upon Birch reduction, 1-butane upon the Birch reduction and Lindlar's catalyst. May I know, or can anyone say, the one who are in the online, can anyone say what is the answers for this one? 1-butane upon the Birch reduction and the Lindlar's catalyst. Cis and trans, or trans and cis, cis and cis, or trans and cis, or any other. If anyone in the online, or if sir, cis butane. If anyone in the online, can anyone say first one is a cis? Birch reduction will give you the, okay, I will say better I will give 1 and 2. Better I will give you the 1 and 2. Say me the 1 will give you the trans, or 1 will give you the cis, or any other. What the 1 will give? Cis or trans or any other? What the 1 will give? Birch reduction. First one is a trans. Second one is a cis, you are saying. If the first one is a trans, second one is a cis, you are saying. But my dear Praneeth, one ఇక్కడ చూడు, నేనేం చెప్పినా ఇది Birch reduction and Lindlar's catalyst, it will give you the geometrical isomerisms కదా. అంటే ఒకటి సిస్ అంటే సపోజ్ ఇట్లా CH3H, ఇది సిస్ కదా. ట్రాన్స్ అంటే ఇక్కడ CH3, ఇక్కడ CH3, ఇక్కడ H, ఇక్కడ H. క్లియర్ కదా. మరి ఇప్పుడు ఏదన్నా కాంపౌండ్ CH3, ఇక్కడ CH3, ఇక్కడ డబుల్ బాండ్ C, if the two same type of the atoms, if it is present to the one carbon, can we say that is a cis and trans? The two same type of the atoms, if it is attached to the one carbon, మరి అది సిస్ అండ్ ట్రాన్స్ అని చెప్తామా? కెన్ వి సే నో జిఐ. మరి ఇక్కడ నీకు సిస్ అండ్ ట్రాన్స్ ఎట్లా వస్తుంది? బికాస్ here the hydrogen already it is there. Here from the Birch reduction, hydrogen will be whatever the hydrogen, it will come from the liquid ammonia. One it will be added here, one it will be added here. అంటే మనకి ఏమొస్తుంది ప్రోడక్ట్? ఇట్లా వస్తుంది. ఇక్కడ ఒక హైడ్రోజన్. మరి ద లిన్లార్డ్స్ క్యాటలిస్ట్కి ఏమొస్తుంది? లిన్లార్డ్స్ క్యాటలిస్ట్ కూడా ఇట్లే కదా వచ్చేది. మరి టూ సేమ్ టైప్ ఆఫ్ ద ఆటమ్స్ ఆర్ అటాచ్డ్ టు ద సేమ్ కార్బన్. మరి నో జిఏ కదా, సో నో రియాక్షన్. దిస్ ఈజ్ వెరీ వెరీ ఇంపార్టెంట్. నో రియాక్షన్ కదా, అందుకే క్రాస్ చెక్ చేసుకోవాలి. ప్రోడక్ట్ ఇవ్వగానే మనము ఒక్కొక్కసారి రియేజెంట్స్ ఇవ్వడు మనకి. ఈ టైప్ ఆఫ్ ద జామెట్రికల్ ఐసోమెరిజం కూడా చెక్ చేసుకోవాలి. ఎందుకంటే టర్మినల్ కార్బన్స్లో ఉన్న హైడ్రోజన్స్ అవి కూడా మనకి మెయిన్లీ ఇట్లా దిస్ టైప్ ఆఫ్ ద క్వశ్చన్స్ వాడు ఐయుపిఎస్సి నేమ్తోని స్ట్రెస్ చేస్తాడు. వాట్ ఈ విల్ స్ట్రెస్ విత్ ద ఐయుపిఎస్సి నేమ్. ఇఫ్ ఈ ఈస్ స్ట్రెస్సింగ్ విత్ ద ఐయుపిఎస్సి నేమ్, then you have to be very careful. Clear? IUPAC name also will play very very crucial role. Directly you have seen that this is a 1-propane upon the Birch reduction and the Lindlards catalyst. You may think that it will give you the cis and trans, but you have to be very careful. It will not give you any reaction. Okay na? Now next. Clear, right? Now that is the second type of the preparations of the alkene has been done. Now third type of the preparations of the alkene, that is dehydrohalogenation. Dehydrohalogenation of alkali halide. Dehydrohalogenation of alkali halide. Dehydrohalogenation of the alkali halide. Now in the dehydrohalogenation of the alkali halide, now what are the reagents we will see? What are the reagents that we are going to use in the dehydration of dehydrohalogenation? Dehydrohalogenation means as a HX it should be eliminated. As a HX it should be eliminated from the reactant, or it should be from the substrate, it should be eliminated. What are the reagents that we are going to see? First one, alcoholic hydroxide of alkali metal, means alcoholic NaOH, KOH, cesium hydroxide. First. Second one, next one we are having the next one, alkali metal amide or NH2, like metal amide in the presence of NH3 ante NaNH2 in the presence of liquid ammonia, or KNH2 in the presence of liquid ammonia. Next, cesium amide in the presence of liquid ammonia. These are the some reagents we are going to use. Next another type of the reagents, third type of the reagents we are going to see, sodium ethoxide or methoxide, or potassium ethoxide or methoxide. This is a potassium methoxide in the presence of which one? In the presence of methyl alcohol. Clear? ఒకవేళ ethoxide తీసుకుంటే sodium ethoxide or sodium butoxide in the presence of ethyl alcohol. In the presence of ethyl alcohol. Done. Next, 3-degree amine, strong base. Okay, 3-degree amine also will be used. Clear? These are the some reagents we are going to use in the which one? In the dehydrohalogenation. In the dehydrohalogenation reactions will follow the E2 mechanism. Which mechanism it will follow? Dehydrohalogenation reaction. Dehydrohalogenation reactions will follow the E2 mechanism. Now in the E2 mechanism, what it should be there? Hydrogen and the leaving group should be trans to each other. Clear? Hydrogen and the leaving group should be the trans to each other. In this CH3, done. Here the halogen. Now here the one hydrogen. Now here the one hydrogen and here the one CH3. Now next, due to the presence of this alcoholic KOH or sodium amide, these are the small bases. Now these are the small bases. Why I am saying this as the bases? Because it is giving its electron density to the hydrogen. Now due to the presence of this small hydrogen, it will attack the hydrogen which is present in the internal carbon. Now due to the internal carbon, this hydrogen it will be taken. Now this bond pair of electron will be shift, and as the halogen it will take the bond pair of electron and it will leave, and based on that it will give you the more stable alkene. What it will give? It will give you the more stable alkene. In this manner, the more stable alkene it will give. Done. This is the product we will get. Clear? If suppose if it is attacked, or if it is taken the hydrogen from the terminal carbon, internal carbon lo unna hydrogen kakunta terminal carbon lo hydrogen తీసుకుంటే, if suppose it has taken the hydrogen from the which one? Terminal carbon hydrogen. ఇక్కడ terminal carbon లో ఒక hydrogen ఉంది కదా, this is 2 and this is H. If it has taken this terminal carbon hydrogen, now this terminal carbon hydrogen, if it is eliminated in this manner, now what it will get? Now we will get the less stable alkene will get. Less stable alkene will get. Terminal carbon hydrogen తీసుకుంటే మనకి ఏమొస్తుంది? హాఫ్ మైన్ ప్రోడక్ట్ వస్తుంది. This is the half మైన్ product. Because less stable alkene, we are having only 3 and 2, 5 alpha hydrogen. Now if the internal carbon containing hydrogen ని తీసుకుంటే మనకి ఏమొస్తుంది? మోర్ స్టేబుల్ ఆల్కిన్ వస్తుంది. This one we call it as a Sedgwick product. Clear? This one we call it as a Sedgwick product. Done? Or else you can take it as a name in this one, Sedgwick product. Clear? Done? Now here, when small base they have given, when we have taken the small base, if suppose if we have taken the bulky base if we have taken CH3, now here the CH2 and here it is a H, now here it is a halogen, now here the H, now here it is a H, now here it is a CH3. Now if we have taken the bulky base, now this is a tertiary butoxide is a bulky base. Tertiary butoxide, if it is want to attack the internal hydrogen, due to the bulkiness, due to the bulky base, internal hydrogen will not be absorbed, because of steric crowd. Because of the steric crowd, it get repel, or it will get repulsion. Due to the repulsion, it will not abstract the internal hydrogen. Then what it will happen? It will abstract the which one? Terminal hydrogen. It will abstract the terminal hydrogen. When it abstracts the terminal hydrogen, now what is the product we'll get? We'll get the half మైన్ product as a stable product. If the bulky base if they have given, blindly believe that the stable product is a half మైన్ product. Which one? Bulky base. If the bulky base they have given, half మైన్ product is a stable. Clear? If the bulky base if they have given, which product is a stable product? Half మైన్ product is a stable. If the small base they have given, which product is a stable product? Sedgwick product is a more stable product. Done? Clear? Next. Here now I will write some questions. You have to say me the answers for it. I will ask the IUPAC name of it. What I will ask? I will ask the IUPAC name of it. IUPAC name aduguta. IUPAC name cheppali meeru. Okay? First one. C2H5O Na. in the presence of C2H5OH. Now what is the IUPAC name of this product? Second one, Pr sodium amide. Sodium amide in the presence of liquid ammonia. Now what is the IUPAC names of first one? A. Let's take this is B. What is the IUPAC name of the A? What is the IUPAC name of the B? What is the IUPAC name of the A and what is the IUPAC name of the B? What is the IUPAC name of the A and what is the IUPAC name of the B? What is the IUPAC name of the A and what is the IUPAC name of the B? What is the IUPAC name of the A? If you know, you can say. If not, you can give the question mark in the chat box. I will say, so that our time will be saved somewhat. A is 2-methyl-butadiene. A is 2-methyl-butadiene. A is 2-methyl-butadiene. 1, 2, 3, 4, 5. Pentene. Okay. Correct. 2-methyl-pentadiene. Okay. Correct, man. That is here. What it will give? Now this is a 2-methyl-butadiene. Next one, B is a 2-methyl-butadiene. 2-methyl-butadiene. Now this is a product. Good. 2-methyl-butadiene and 2-methyl-butapentene. This is about the which one? This is about clear? Now next, if suppose stereochemistry questions, if they ask stereochemistry questions based on the E2 elimination, they are asking. If the stereochemistry question based on the which one? E2 elimination, if they are asking. Now this is a CH3. Now this is a Br. Done. Now here, next case, here it is a CH3. Now here it is a Br. Done. Now upon sodium amide, let's take in the presence of liquid ammonia. Done. Here also sodium amide in the presence of liquid ammonia. Okay. Done. Here. Now what is the product we will get? What I said? Now bromine and the leaving group and the hydrogen. Leaving group and the hydrogen should be trans to each other. Leaving group and the hydrogen should be which to each other? Trans to each other. You know the answer for this one? Same with the IUPAC name. Same with the IUPAC name. If you know the product, same with the IUPAC name. If not, give me the question mark. I will say. If you know the product IUPAC name, you can say. If not, you can give me the question mark. I will say. Here also A and B. Here also A and B. A IUPAC name and the B IUPAC name. If you know the A IUPAC name and the B IUPAC name, you can say. If not, give me the question mark. I will explain. And cross check whether the given substance is a trans or cis. In the cyclohexane 1, 2 position, 1-methyl cyclohexene sir. First one కాదు అందుకే నేను అడిగిన. డోంట్ నో సార్. ఓకే ఫైన్, చెప్తాను. ఇప్పుడు ఇది 1, ఇది 2 కదరా. ఇది 1 and 2. ఒకటి వెజ్లో ఉంది, ఒక డాటెడ్లో ఉంది. ఒకటి వెజ్లో డాటెడ్లో 1, 2లో ఇది ఏమవుతుంది? ట్రాన్స్ కదా. ఇప్పుడు దీన్ని సైక్లిక్ ఫార్మ్ రాయి, దీన్ని చైర్ కన్ఫార్మర్ రాయి. ఫస్ట్ దాన్ని చైర్ కన్ఫార్మర్లా ఇది చైర్ కన్ఫార్మ్, ఇది ఇప్పుడు ఇక్కడ ఇట్లా ఉంది. డన్. బల్కీ గ్రూప్స్ ఎప్పుడు ఈక్వటోరియల్లో ఉండాలి. బిఆర్ ఇస్ అ మోర్ బల్కీ రైట్. ఇది ఎక్కడ ఉండాలి? బల్కీలో ఉండాలి. బల్కీ కాబట్టి ఇది ఎక్కడ? ఈక్వటోరియల్లో ఉంది. మరి ఇక్కడ ఏముంది? CH3 ఇట్ ఈస్ ఎట్ ద విచ్ పొజిషన్, యాక్సియల్ పొజిషన్. డన్. ఇప్పుడు మనకి ఇక్కడ హైడ్రోజన్ ఉంది, హియర్ ద హైడ్రోజన్ ఇట్ ఈస్ దేర్. డన్. హియర్ ద one hydrogen it is there, here the one hydrogen it is there. Clear? Now here the which hydrogen, ఒకటి వెజ్ ఒకటి డాటెడ్ ఉంటుంది కదా హైడ్రోజన్. ఇప్పుడు ఈ రెండు డాటెడ్ హైడ్రోజన్, ఇది వెజ్ హైడ్రోజన్, ఇక్కడ వెజ్ హైడ్రోజన్, ఇక్కడ నుంచి హైడ్రోజన్ నువ్వు అనుకున్నావు, ఇక్కడ నుంచి హైడ్రోజన్ ఇక్కడ పోయి సో 1 మిథైల్ సైక్లోహెక్సేన్ ఇస్తుంది అనుకున్నావు. కానీ నేనేం చెప్పిన, లీవింగ్ గ్రూపు హైడ్రోజన్, దిస్ లీవింగ్ గ్రూప్ హైడ్రోజన్ ఏ పొజిషన్లో ఉండాలి, ట్రాన్స్లో ఉండాలి. కానీ మనకి ఇక్కడ ఏమున్నాయి, సిస్లో ఉన్నాయి. ఈ రెండు సిస్లోనే ఉన్నాయి కదా రెండు. ఇక్కడ వెజ్, ఇక్కడ ఇది డాటెడ్లో ఉందంటే హైడ్రోజన్ వెజ్, సారీ ఇక్కడ హైడ్రోజన్ వెజ్లో, సారీ CH3 వెజ్లో ఉందంటే హైడ్రోజన్ డాటెడ్లోనే ఉంది కదా. మరి ఇక్కడ లీవింగ్ గ్రూప్ కూడా డాటెడ్లోనే ఉంది. మరి రెండు డాటెడ్లో ఉన్నాయంటే సిస్2 ఇచ్చేద్దరు కదా ఇది. మరి ఇక్కడ నుంచి హైడ్రోజన్ ఎట్లా పోతుంది, పోదు. మరి ఇప్పుడు ఎక్కడి నుంచి పోతుంది, ఈ హైడ్రోజన్ నుంచి పోతుంది, ఈ వెజ్ హైడ్రోజన్ నుంచి పోతుంది. ఈ వెజ్ హైడ్రోజన్ నుంచి ఇక్కడికి వచ్చి ఈ Br ఇట్లా గుడ్ లివింగ్ గ్రూప్గా వెళ్ళిపోతుంది. అప్పుడు మనకి ఏమొస్తుంది, ద ప్రోడక్ట్ విల్ గెట్ 3-మిథైల్ సైక్లోహెక్సేన్ వస్తుంది. 3-మిథైల్ సైక్లోహెక్సేన్ వస్తుంది. ఈ స్టీరియోకెమిస్ట్రీ ఇచ్చినప్పుడు యూ హ్యావ్ టు బి వెరీ కేర్ఫుల్. దెన్ 1-మిథైల్ సైక్లోహెక్సేన్, దెన్ B is 1-మిథైల్, then the B is 1-methyl cyclohexane. B 1-methyl cyclohexane, B 1-methyl cyclohexane. ఇప్పుడు B ఏమవుతుందంటే 1-methyl cyclohexane అయితే. క్లియర్. B is a 1-methyl cyclohexane. Bలో ఎట్లా, ఇక్కడ ఇక్కడ ఏముంటుంది, ఈ డాటెడ్ కదా. కానీ Bలో కూడా 1-methyl cyclohexane, Bలో కూడా 1-methyl cyclohexane రాదు. Bలో కూడా Bలో రాదురా. ఎందుకంటే ఇక్కడ ఉన్న డాటెడ్ హైడ్రోజను, ఇక్కడ ఉన్న వెజ్ హైడ్రోజను రెండు సిస్2 ఇచ్చేదారు కదా. అక్కడ కూడా 1-methyl cyclohexane రాదు. అక్కడ కూడా మళ్ళీ ఇదే వస్తుంది. సారీ, అక్కడ కూడా సేమ్ ప్రోడక్టే వస్తుంది మళ్ళా. ఇది హైడ్రోజనా, ఇక్కడ హైడ్రోజన్. ఇప్పుడు ఇది ఇక్కడికి పోయి ఇది ఇట్లా వెళ్ళిపోతుంది. సేమ్ ప్రోడక్టే. A and B both are same. A and B both are same. A and B both are same. So you have to be very careful when this type of the product they are given. Or ఇట్లాంటి క్వశ్చన్స్ ఏదైనా ఇస్తే స్టీరియోకెమిస్ట్రీ యూ హ్యావ్ టు క్రాస్ చెక్. ట్రాన్స్ హైడ్రోజన్స్ యూ హ్యావ్ టు క్రాస్ చెక్ అండ్ యూ హ్యావ్ టు డూ ద ఆన్సర్. ఓకేనా? నెక్స్ట్, ఇఫ్ సపోజ్ న్యూమన్ ప్రొజెక్షన్ ఇచ్చినాడు. ఇప్పుడు ఇట్లా న్యూమన్ ప్రొజెక్షన్ ఇచ్చినాడు. న్యూమన్ ప్రొజెక్షన్ ఇచ్చి దే విల్ ఆస్క్ యూ ద వాట్, దే విల్ ఆస్క్ యూ టు ఫైండ్ ద ప్రోడక్ట్. న్యూమన్ ప్రొజెక్షన్ ఇచ్చి ప్రోడక్ట్ ఫైండ్ చేయమంటే, ఇప్పుడు ఇట్లా న్యూమన్ ప్రొజెక్షన్ ఇచ్చి ప్రోడక్ట్ ఫైండ్ చేయమన్నాడంటే, దెన్ లీవింగ్ గ్రూప్ హైడ్రోజన్ 180 degreesలో ఉండాలి. ఓకేనా? వాట్ ఇట్ షుడ్ బి దేర్, లీవింగ్ గ్రూప్ అండ్ హైడ్రోజన్ షుడ్ బి 180 degree. ఇప్పుడు ఎక్కడుంది ఇది Cl, ఈ కార్బన్లో హైడ్రోజన్ ఇక్కడ ఉంది. ఈ కార్బన్ ఇది ఫ్రంట్ కార్బన్ కదా, ఇదేంది బ్యాక్ కార్బన్, రేర్ కార్బన్. ఈ రేర్ కార్బన్లో Cl ఇక్కడ ఏంది ఎలా ఉండాలి, 180 degreesలో ఉండాలి. అంటే ఏం చేయాలి, ఫస్ట్ కార్బన్ ఫిక్స్ చేసి సెకండ్ కార్బన్ని రొటేట్ చేయాలి. వెన్ వీఆర్ రొటేటింగ్ ద సెకండ్ కార్బన్, దెన్ వాట్ ఇట్ విల్ హ్యాపెన్, హియర్ ఇట్ ఈస్ ద CH3, నౌ హియర్ ఇట్ ఈస్ ద H, నౌ హియర్ ఇట్ విల్ బి ద D. Now the when I was rotated the Cl, now here it will get the Cl. Now here it will get the what it will get, here కొంచెం it reduce చేస్తే ఇక్కడ CH3. Now here it will get the hydrogen. Now these two are the what, 180 degrees trans to each other. Now in this manner the trans to each other it will be eliminated. When these are eliminated in the form of the trans, what is the product we will get, here the CH3, one CH3 double bond, here the D, one CH3, sorry, this carbon and here it will get the CH3 and here it will get the H. Here it will get the H. Clear? ఇప్పుడు ఈ కార్బన్, ఈ ఫ్రంట్ కార్బన్ చూడు, ఈ ఫ్రంట్ కార్బన్కి ఇక్కడ చూడు, ఈ ఫ్రంట్ కార్బన్కి ఈ Cl ఇక్కడికి ఎలిమినేట్ అయితే, ట్రాన్స్లో ఎలిమినేట్ అయితే ఈ CH3కి ఈ కార్బన్కి D ఉంది. యూ కెన్ సీ దిస్ కార్బన్ ఇట్ ఈస్ హ్యావింగ్ ద 1 CH3 1 D. మళ్ళా ఈ రేర్ కార్బన్కి ఏమేమి ఉంది, రేర్ కార్బన్కి ఒక CH3 ఒక హైడ్రోజన్, రేర్ కార్బన్కి ఒక CH3 హైడ్రోజన్. క్లియర్? డన్. నెక్స్ట్ నెక్స్ట్ ఇంకొకటి, ఇప్పుడు CH3 ఉంది ఇట్లా. నౌ దిస్ ఈస్ ద డిటీరియం అండ్ హియర్ ఇట్ ఈస్ ద హైడ్రోజన్ and here it is a CH3. Okay, now here it is a CH3, now here it is a chlorine, now here it is a one phenyl ring. Okay, ఇప్పుడు చూడు, ఇక్కడ హైడ్రోజన్, ఇక్కడ క్లోరిన్, ఇక్కడ హైడ్రోజన్ క్లోరిన్, మనం ఏం చేయాలి దాన్ని, until both should be the 180 degree, until 180 degrees కి రొటేట్ చేయాలి కదా, ఫిక్స్ చేసుకొని 180 degrees కి రొటేట్ చేయి. we have to rotate to the 180 degree. Here the D, here the hydrogen. Now if you rotate to the 180 degree, now here this is a Cl, ikkada emaytadi, ikkada phenyl, here it will become phenyl, here it will become CH3, now here it will become CH3. Now both has become the trans, ikkada trans loki vachesinayi kada. Now trans loki vachesina tarvata product rashi. How the product you will write? Now here the CH3, now this carbon, here having the deuterium, and here the carbon, here the carbon, one it is having the CH3, one it is having the pH. Now in this manner the alkene will get. In this manner what you will get? Alkene you will get. Done. Now this is about the, with the which one? This is about the, with the stereochemistry of Newman projection. ఇప్పుడు Sahar's projection ఇస్తే, if suppose if they have given the Sahar's projection, now this is a Sahar's projection. Here it is a Cl, now here it is a pH, now here it is a CH3. Then now the Sahar's projection if they are given, then make it to the 180. Then after that you write. Clear? Try to write the product for this one. Try to write the product for this one. Next. Next one we are having next one dehalogenation reaction. Next one we are going to see which one, dehalogenation reaction. Fourth type of the preparation that we are going to see, that is dehalogenation reaction. Dehalogenation reaction we are going to see. What is the meaning of the dehalogenation reaction? Dehalogenation reaction ఏం లేదు, ఇక్కడ C, here the X, here the C, here the X, here the, clear? Now in the presence of sodium iodide, in the presence of acetone, sodium iodide in the presence of acetone, or zinc dust heating, ఏం లేదు, Zn+2 కదా, Zn+2 it will take the X from here, ఈ బాండ్ ఇక్కడ షిఫ్ట్ అవుతుంది, యాజ్ హాలోజన్ ఇట్ విల్ బి ఎలిమినేటెడ్, అప్పుడు ఏమవుతుంది, ఇక్కడ C డబుల్ బాండ్ C, అండ్ what it will get, here it will get one, you will get the either NaX or ZnX2 or ICl. క్లియర్? డన్. లేకపోతే మీకు కన్ఫ్యూజ్ అవుతుంది అంటే ఎలా సార్ అది మెకానిజం చెప్పండి అంటే, ఐ విల్ సే వెయిట్. Here the iodine, from the iodine we are having the I minus. This I minus it will take the, which one? It will take the deficiency of the X. When this bond pair of electron they have given, it will take the, which one? It will form the bond with the X plus. Then after, when the sigma bond has been delocalized here, what it happened? This halogen will be eliminated and will get the alkene in this manner. Now this is a one dehalogenation reaction. Clear? Dehalogenation reaction. Now next, this is about the preparations of the dehalogenation or dehalogenation reaction, and here we have prepared the which one? Alkanes. Now we'll see the physical properties of the alkanes. Now the one who are in the live will continue the physical properties of the alkene. The chemical properties of the alkanes continue చేద్దామా, or should I stop it here? లేకపోతే రేపు చూద్దామా? అప్ టు ఫిజికల్ ప్రాపర్టీస్ చూసినాం కదమ్మా. We are stopping the, should I stop the class or should I continue? Anyone in the live, the students who are in the live, they can text. మీరు కంటిన్యూ చేయమంటే I can continue, లేకపోతే will continue tomorrow sir. Okay, no one is there I think. Okay, సరే రా, fine. I was ending the class here. రేపు chemical properties of the alkanes రేపు చూద్దాంలే. We'll see the chemical properties of the alkanes tomorrow. Okay, Nana, I was ending the live. We'll see the chemical properties of the alkanes tomorrow. Okay, bye, good night. Okay, bye, good night. Okay, bye. Okay, bye.